Hello, my name is Olivier Jeunen, and this is a short teaser video for a common misassumption in online experiments with machine learning models. Imagine you're the web chair for the RecSys conference and you have a great idea to improve the website. In fact, you want to deploy a machine learning model that is going to try and personalize page layout and design based on some data that you have. You might have two alternative models and you need to decide which one is best. Now, this is easy, right? We just do an A/B test, we randomize users to either model A or model B, and then we measure what happens. We can then simply compare these measurements and we have a winner. Great. What could possibly go wrong here? Well, A/B tests follow the same statistical reasoning as randomized controlled trials, or RCTs. An example from the early literature describes how you could measure the effectiveness of fertilizer A versus fertilizer B. You find two plots of land, you fertilize them accordingly, you wait a bit, and then you measure crop yield. If you repeat this often enough, the difference in average crop yields will be an unbiased estimator for the average treatment effect of switching fertilizers. One important reason why this works is something called the stable unit treatment value assumption, or SUTVA. SUTVA implies that whichever fertilizer we choose to apply to one plot of land does not affect the measured outcome on other plots of land. Now, imagine instead a situation where our plots of land neighbor each other, and after heavy rain, fertilizer spills over between the plots. Now, this will clearly muddy the experiment, and we can no longer measure the treatment effect. Indeed, SUTVA is violated. Now, how does this apply to our online experiment? Well, we have two models that are interacting with users. We log these interactions, and we use them to inform what the model should do in the future, either directly as training data or to inform features such as the average popularity or maybe the click-through rate for an item. We either update models or features, generate new interactions, log them, and this cycle repeats. When these two models and hence data sources are kept fully separate, we're fine. SUTVA holds. But this is seldom how A/B tests run in practice. Indeed, we will have two models running in parallel, and the data that is generated is then pooled together. This pooled data informs future model decisions, either as training data or as features, and this cycle continues. Such cases should come with a big warning sign. SUTVA is violated, and differences between observed metrics no longer provide unbiased estimates of the average treatment effect. This is important both for business decisions and for A/B testing results that are reported in the scientific literature. Some open questions remain, though. Does this bias ATE estimates in a way that changes downstream decisions? Is there some way we can maybe quantify this bias? Are the advantages of having pooled data sometimes worth it? And just maybe, should we stop treating A/B test results as infallible? I hope you find these questions as interesting as I do, and I look forward to discussing them at the workshop.